is a video going over our Chapter 1 test review. So our first learning target is being able to identify the characteristics of parent functions. So the first thing we want to do is to be able to name the function. When I look at this graph, I notice that there's two separate pieces, and I also have vertical and horizontal asymptotes. So this function is a rational function. For the transformations, normally rational functions have their asymptotes on the x and y axis, where I'm currently drawing in purple, but that has been shifted to this point over here. So I have moved to the left 1 and down 3. And that's going to help me write my equation. So in order to write my equation, we're using the general form equation of a rational function. So I'm going to write y equals, and since there is no stretch or reflection, my numerator is just going to be 1, and it's x minus h underneath my fraction. So h is our movement to the left or to the right. So since I'm moving to the left 1, that means in my denominator it's going to be x plus 1. And when I'm moving down 3, that's my k, and that's what I'm adding or subtracting to the side of my function. So in this case, I'm subtracting 3 since I am moving down 3. For my domain, I need to see what is happening to my graph horizontally, so moving from left to right. So I can see this piece goes from negative infinity up to my asymptote. So we're looking at x values for domain and range. So it goes from negative infinity to negative 1. And I have my second piece for my x values that starts at negative 1 and heads towards positive infinity as I move to the right. So since my rational function has two almost separate graphs, I do have two pieces for my domain. So this would be negative 1 to positive infinity. For my range, very similar idea, but except we're looking at our horizontal asymptote because that's going to create a break in our range. So for our range, we're going from the bottom up. So I'm going from negative infinity, so looking at my y values, up to negative 3, and then this other piece goes from negative 3 up to positive infinity. So my first range, negative infinity to negative 3, and then negative 3 to infinity. So you can kind of see with my domain and range, if you look closely, right here, these are our asymptotes, and for our domain and range, it separates our domain and range based off of those asymptotes. So equations of our asymptotes, I have a vertical asymptote at x equals negative 1, and a horizontal asymptote at y equals negative 3. Now for our intervals of increasing or decreasing, as I move from left to right, I'm decreasing because I'm going down. So that first interval goes from negative infinity to negative 1. And then going to my other piece, still moving from left to right, it is decreasing from negative 1 to infinity. Oh, that's all decreasing. I just wrote it underneath increasing. Whoops. Let's go ahead and move this. So this right here is my answer for decreasing. I'm going to rewrite it. So I have negative infinity to negative 1 and negative 1 to infinity. I'm going to go ahead and erase this. And we actually do not have any parts of our graph that are increasing. So we're just going to write none. There we go. All right. So let's take a look at our next graph. Our next graph is a U-shaped graph, which I recognize as a quadratic. For the transformations, normally my vertex for my quadratic's at the origin, but it has been shifted to this point over here. So in order to get from my origin to that point, I am moving to the right 1 and up 2. And again, those transformations are going to help us write our equation. So I have y equals x minus h, so I move to the right one, so x minus 1 squared, and then plus 2. So those transformations represent your h and your k. For my domain, looking at all of my possible values of x, that's negative infinity to infinity. For my range, the lowest my graph goes is to 2, and it's going to head up towards positive infinity. Now at that 2, I'm going to use a bracket because this point is actually included on my graph. Equations of asymptotes, this does not have an asymptote, so that is none. And then increasing and decreasing. So I'm going to travel from left to right. So as I move from left to right, right now I am decreasing, and then right there it switches from decreasing to increasing. So my interval for decreasing is negative infinity up to 1. You're always using x values. And then for increasing, it goes from 1 to infinity. Okay, now moving on to learning target number 2. So I can describe functions, domain, range, increasing, and decreasing. So kind of a continuation of what we were just doing, just with an arbitrary graph as opposed to a parent function. So if I look at my domain moving from left to right, the furthest my graph goes to the left is at 0. And then the furthest it goes to the right is towards 9, always using my x values for range or for domain. So my domain goes from 0 to 9. Now I do need to pay attention to whether I'm going to use brackets or parentheses. I'm going to go ahead and put a bracket around the 0 because this was a closed circle. I'm going to put a parenthesis around the 9 because that was an open circle. Same idea for the range, except I'm looking at my y values. So the lowest my graph goes is to 1, and the highest my graph goes is to 8. So my range is going from 1 to 8, bracket around the 1 because of the closed circle, parenthesis around the 8. I don't know why I wrote an infinity. Parenthesis around the 8 for the other piece of my range. Okay, increasing and decreasing. So traveling from left to right, this piece right here is increasing. So that is from 0 to 2. This piece is decreasing, and that's from 2 to 4. And then this piece is increasing once again, and that is from 4 to 9. And voila, let's do another one. Okay, domain, I can see these arrows on the side telling me that it's going to keep going to the left and keep going to the right, so that means my domain is all real numbers, which as an interval is negative infinity to infinity. For my range, the lowest my graph goes is right here at 0, and it's going to head up towards positive infinity. Now for that 0, since these points actually exist on my graph, I'm going to go ahead and make that a bracket. Now for increasing and decreasing, traveling from left to right, so over here, I am decreasing this first blue section, so that is negative infinity to negative 1. From here, it switches from decreasing to increasing, and that is from negative 1 to 0. Then it switches back to decreasing. That's 0 to 1. And finally, it switches once again to increasing, and that would be 1 to infinity. All right, our next learning target, continuing from learning target number 2, is identifying even and odd functions. So an even function, if you were to look at the graph, an even function is symmetrical over the y-axis. So for example, a parabola is symmetrical over the y-axis, so that one would be even. For an odd function is symmetrical with rotational symmetry. So if I look at this and were to rotate it 180 degrees, it would land right there in that third quadrant. So that's what you're looking at graphically. So it's up to you on if you want to take these and put them into your calculator and look at the graphs, or if you want to do it algebraically. If you're going to do it algebraically, you're just picking numbers for x. So for example, +2 and -2. So I'm going to find my value when x equals 2. I can plug it in and find p of 2. I'm just going to plug it in right into my equation, and that is going to give me the value of 11. And plug it right in for x. I'm also going to test it out when x is -2. So when I plug in -2, I'm also going to get +11. Now, since these two are exactly the same, that is telling me that this right here is an even function. For letter B, I'm going to do the same thing. If I want to do it algebraically, I'm going to choose 2 and -2. When I plug in +2 in for x, I get 27. When I plug in -2 for x, I get +3. Now, if I look at these two numbers, they are totally different, so that makes this function neither. And if you were to graph this, what would end up happening, I'm going to draw a quick sketch of the graph. You would have a quadratic, so it's a parabola. And it's over here in the second quadrant. And you can see that that's not symmetrical over the y-axis, and it doesn't have rotational symmetry. So that would be neither as well. All right, continuing to solve algebraically, I'm going to plug in 2 and -2. When I plug in +2 into our m function, I get 64. When I plug in -2, I get -64. Now, when I compare these two, they are opposites. And when those numbers are opposites, that tells me that my function is odd. So even will tell you the same number. Odd will tell you same number, opposite signs, and neither will just be two totally random numbers. Or you can graph it and tell me that it is symmetrical over the y-axis for it being even, or it has rotational symmetry for it to be odd. Okay, next up, piecewise functions. So as you can see, I already plugged this stuff into a calculator. So it's very helpful if you have a graphing calculator to be able to work through graphing these piecewise functions. I always like to graph my transitional point first, or I also call it my boundary. So that's going to be this dotted line right here, and that's going to separate my two pieces. So the first piece is that x plus 3 squared plus 2, and I plugged it into y equals, and it gave me these values in the table. Now what I'm looking for is, it is for when x is less than or equal to -1. So I'm going to start at -1, and I'm going to use all of these values that are less than -1. So at -1, my point is 6. So I'm going to plot the point -1, 6. But before I plot it, I need to pay attention to my inequality to see if it's going to be an open or a closed circle. This one's going to be an open circle because it doesn't have the or equal to. So I plotted this one. Now I'm going to plot -2, 3. Since I'm not touching that transitional point or that boundary, you don't have to worry about open or closed circles. They're just regular points. I'm going to keep graphing. -3, 2. -4, 3. And I can see I'm already getting that parabolic shape, that U-shaped graph for my quadratic. And -5, 6. So I can go ahead and connect these, and we got our nice quadratic function. For this linear function, that's over here, -3x plus 1. Again, I'm going to start by looking at -1 first, And this is for x is greater than or equal to -1. So now I'm going to look at my table at all of those numbers that are greater than or equal to -1. So at -1, my value is 4. This one's going to be a closed circle because I do have the or equal to underneath my inequality. And then I'm going to start plotting points. So -1, 4, 0, 1, 1, -2, and 3, -8, and I'm off the graph, so I'm not going to worry about it anymore. I'm going to go ahead and connect these points, and you can see your linear piece for this piecewise function. So you're plugging the functions into your calculator and using the table values to get your points to sketch a graph. Okay, letter B is a continuation of letter A. It is using the same function of f of x, except it has a transformation. So right here, this +1 in the parentheses, that's telling me that the function is going to move to the left 1. And this -1 on the outside is telling me that we are moving down 1 as well. Now, in order to find the transformed function, what we're going to do is we are going to use our original f of x, but we're going to change our input. So instead of having x's right here, I am going to replace it with x plus 1. So I'm going to write my original f function. So I have my parentheses, but instead of x, I'm putting x plus 1. I'm going to go ahead and continue to write my f function. So I have x plus 1 squared plus 2. And then I still have this -1 on the side, so I'm going to go ahead and tack it on at the end. I'm going to do the same thing for my other piece of that f function. I'm going to write my -3. But instead of x, I have this new input of x plus 1. Continuing with my f function, it's -3x plus 1, so I got my plus 1. But then I'm also tacking on this -1 in the end. Now from here we can simplify what we can. So I have x plus 1 squared. 2 minus 1 is 1. So plus 1. I feel like I messed up somewhere. Oh, shiitake mushrooms. Here it is. I'm going to erase. I forgot this plus 3 right here. Okay, so I have my x plus 1 plus 3 squared plus 2. So I forgot this piece right here. Sorry about that. Plus 2 and then -1. There we go. Okay, let's keep going. So now I can combine like terms. So I have x plus 1 plus 3 is 4. Squared, 2 minus 1 is 1. For my other one, I have -3 x plus 1, and then 1 plus 1 is just 0, so it's going to cancel out. We could also write this as, I'm going to go ahead and put it in pink underneath, -3x minus 3 if you choose to distribute that 3. Now, for the other portion of our piecewise function, we also need our inequalities. So if x is less than whatever, and if x is greater than or equal to whatever. Now, what's going to happen is we have this right here. So that was our boundary, our transitional point, and it has now been shifted to the left 1 unit. So if I were to look at my graph, at -1, we had our transitional point or that boundary, but now I'm moving it to the left 1 unit. So where is it at now? It's at -2. So now my inequality is going to be -2 instead of -1. And this right here is our final answer. Again, either of these should be fine. Okay, let's graph another piecewise. So once again, I already graphed this in the calculator. So here is my first function. Over here, we're going to use the table. It is when x is less than or equal to -3. So I'm going to start at -3 and head in that direction for my points. Again, I like to draw this little dotted line to separate my two pieces. And let's plot some points. So negative 3, 1, that's going to be a closed circle because my inequality has the or equal to. Negative 4, negative 1, negative 5, negative 3. 1, 2, 3. And here's my linear piece. For my other piece, this one's absolute value, so I should recognize that my graph is going to end up being a V-shaped graph. Again, I'm going to start at negative 3, separating my table, and I want all the numbers that are greater than negative 3, so that's heading in this direction. So my first point is negative 3, 5. This one's going to be an open circle because I don't have the line underneath that inequality. Negative 2, 2, negative 1, 5. Ooh, I can already see that V. What else is there? 0, 8. All the way up here. And here is my V. One thing that I want you to notice is how skinny that V is, and that's because there is a stretch. Look at this. 3 in the front, that's going to create a vertical stretch. So that's why your absolute value graph looks a lot more narrow than it usually does. Okay, so that's it for learning target number 3, graphing piecewise functions. Let's go on to target number 4, which is function operations. So if I look at the directions, I have a ton of functions here. So I really need to make sure that I'm paying attention to which function that I'm using. So I have r of x is x squared minus 4, m of x is negative 2x plus 5, p of x is 9x minus 7, a of x is 7x squared minus 2, and b of x is the square root of 3x plus 1. And I want to find all sorts of stuff. So first thing I notice for number 1 is I have this little negative 1 right here. That tells me that I need to find the inverse. So normally my b function is the square root of 3x plus 1. So I can write it as y equals square root of 3x plus 1. Since I am trying to find the inverse, I'm going to use the switch and solve method where I'm going to switch my variables. So instead of y equals, I have x equals square root of 3y plus 1. And then from here, my job is to solve for y. So I notice my 3y plus 1 is stuck underneath my radical. So I need to get rid of my radical first by squaring both sides. So I have x squared equals 3y plus 1. From here, I'm going to subtract 1 from both sides and divide both sides by 3. So now I have my inverse, b inverse of x equals x squared minus 1 all over 3. Number 2 is subtraction. So I'm going to start by writing my m of x first. So m of x is negative 2x plus 5 minus p of x, which is 9x plus 7. Minus 7, sorry. Now, since I am subtracting this p of x, I'm going to put it in parentheses. That way I remind myself that I am subtracting both of those terms. So I'm going to go ahead and distribute the minus into the parentheses. So that gives me negative 2x plus 5 minus 9x plus 7. And then from here, I can combine my like terms. So I have negative 11x plus 12. And that is my final answer. All right, let's do some more. Number 3. So number 3 is the composition. And the way that I can tell it's the composition is because I have a function inside the parentheses for another function. So that means I'm taking p of x and plugging it into my r function. So here's another way of looking at this. So I have r of, and I'm going to write down p of x. P of x is 9x minus 7. So that means this 9x minus 7 is going to be my input for x into my r of x function. So as I write this, I'm going to write x squared minus 4, but instead of x, I'm putting 9x minus 7. Now from here, we just got to simplify. So I'm going to rewrite this 9x minus 7 times another 9x minus 7 because I want to make sure I'm multiplying correctly. I'm going to distribute. So 9x times 9x is 81x squared. 9x times negative 7 is negative 63x. Another negative 63x plus 49. And I've got this minus 4 on the end that I cannot forget about. A lot of people have a tendency to forget about it. From here, combine like terms. I have 81x squared minus 126x plus 45. Now, a very common mistake. A lot of people mistake questions like number 3 for multiplication. So they see r of p of x and think it's multiplication. Now, if this were a multiplication problem, it would look like this, r of x times p of x. So make a little mental note to yourself. This is the composition. This is multiplication. They mean two totally different things. Okay, number 4. So my input into my p function is x minus 3. So I'm going to start by writing my p function. I'm going to replace my x with x minus 3. So here we go. So p function is 9x minus 7. So I'm going to do 9 blank minus 7. Inside my blank is going to go x minus 3. And then I've got this plus 9 at the end. So I'm going to add it at the end. From here, we can distribute. 9 times x is 9x minus 27 plus 2. 9x minus 25. And voila. All right, I think there's 2 more for this learning target. Yep. Number 5 is another composition. Again, I see I have a function in a function. So I can rewrite this as a of, and b of x is the square root of 3x plus 1. So I'm going to go ahead and write my a function, which is 7x squared minus 2. So I'm going to do 7, but instead of x, I'm going to leave it as a blank. Blank squared, what was the rest of it? Minus 2. And in that blank is going to be this expression, square root of 3x plus 1. From here, simplifying, square and square root cancel. So I have 7 times 3x plus 1 minus 2. Distribute the 7. That's 21x plus 7 minus 2. Continue to combine like terms, and I have 21x plus 5. And last but not least, we have another inverse function. So I'm going to go ahead and list my a first. So I'm going to write it as y equals 7x squared minus 2. But since I'm trying to find the inverse, I'm going to switch my x and my y, and I'm going to solve. So I can start by adding 2 to both sides. Divide both sides by 7. So I have x plus 2 over 7 equals y squared, and then I am going to square root. Now, when you square root, you typically have 2 answers, a positive and a negative. I don't know why I wrote F. It's supposed to be A. So when I write my final answer, I'm going to do plus or minus, because when you take the square root, it could be a positive or a negative for your solutions. Square root of x plus 2 over 7. And that goes back to the fact that negative 4 squared is 16 and positive 4 squared is 16. So if I were to solve for this equation, then I would have 2 solutions, positive 4 and negative 4. So that's why we have that plus or minus on that particular inverse, as opposed to any of the other ones. All right, so that does it for function operations. Last learning target, transformations. So I'm going to go ahead and pick points. I like to work with specific points. Some of these questions I'll make a table. Others I will not, and I'll explain which scenarios I make a table and which ones I don't. This one I'm going to make a table, and the reason I'm going to make a table is because I'm dealing with some multiplication over here. So this is a vertical stretch of 2, and I'm also moving up 1. So I'm going to go ahead and start by looking at my original ordered pairs. So I have -2, -2. I have 0, -1, 2, 1. What else do I have? I feel like I skipped a point. Oh, I forgot -1, 1. There we go. Let's try this again. So -2, -2, -1, -1. That's the one I skipped. 0, -1, 2, 1, and 4, -1. Whoops, I didn't write -4. 4, -1. Okay. So if I think about my transformations, vertical stretch of 2 is going to change my y's. Also, moving up 1 is going to change my y's. So what ends up happening is my y values are going to be the only ones that change. So I'm going to take 2 times my y value plus 1. So I'm just going to go ahead and extend this table. My x values are going to stay the same. So all of these y values I'm going to multiply by 2 and add 1. So -2 times 2 is -4, plus 1 is -3. 2 times -1 is -2, plus 1 is -1. Another -1. 2 times 1 is 2, plus 1 is 3. And 2 times -1 is -2, plus 1 is -1. So now I'm going to plot my new points. So my first point is -2, -3. -1, -1. 0, -1. 2, 3, 4, -1. And then I can use the original shape as my guide to see what my new shape is going to be. And you can see that this one had that vertical stretch because you can see, particularly right here, that this triangle is a little more narrow and stretched vertically. So there's letter A. For this one I'm not actually going to make a table. And here is why. Because there is no stretch or compression. So if I look at my transformations, I am moving to the right 3 and down 2. So I can literally just take these points, move to the right 3 and down 2, and not have to worry about a table. So I'm going to take this first point over here, move it to the right 3, 1, 2, 3, down 2. There it is. Next point, 1, 2, 3, down 2. 1, 2, 3, down 2. This one up here, 1, 2, 3, down 2. Oh, and I've run out of space on my graph. Oh no. That's okay. We can just go with it. There is my little triangle piece. And then this sucker is just going to keep going in this direction. There we go. What a bummer. Ran out of space. Okay. Let's do the next one. So again, I didn't use a table for this one because I was literally just counting, moving left and right, which is fine. I only like to use a table when I'm dealing with reflections. Actually, maybe not reflections, but stretches and compressions. So this one, I can see I have a reflection, and that's over the x-axis. And I'm also moving to the left 2. So again, I'm going to go ahead and do this without a table. And I'll kind of show you, I'll do the reflection points first in blue, and then I'll move it to the left 2, and then that'll be my final set of points. So I'm going to reflect over my x-axis, so this first point's over here. Reflecting over my x-axis. Reflecting over my x-axis. There we go. And now I can take all of these points and move them to the left 2. So I'm going to do this in purple. So my final set of points is what I am currently doing in purple. So there is this portion of the graph, my flat piece, and the rest. Now, if you did want to do a table, which is fine, I'll show you what your adjustments would have to be. So I have -2, -2, -1, -1, 0, 1. What else do we have? 2, 1, and 4, -1. So a reflection over the x-axis is going to take all of my y's and change their values by switching them from a positive to a negative. So I'm taking all my y's and multiplying it by -1. If I am moving to the left 2 units, that affects my x values. So then I would take my x values and subtract 2 units because I am moving to the left. So my first point would be -4, +2, which is exactly what we had over here. So if you wanted to use the table, you would just continue to fill out that table and it would give you all of the points that I had in purple. All right, next, a horizontal. So in the parentheses, I have a 2 times x. That is going to be a horizontal compression. And this -1 means I am moving down 1. And since I am dealing with a stretch or compression, I am actually going to make a table. You know, I could have saved myself a lot of time by adding a table of points to my slides beforehand. That way, I'm not rewriting the same thing over and over again. But I did not do that, so I'm just going to keep writing. So I have 2, 1, and then 4, -1. Okay, so for my transformations, horizontal compression, I'm going to take all of my x's and divide it by 2. So anything that's horizontal, whether it's a stretch or compression, you're dividing your x value by that number. And moving down 1 means I'm taking my y's and subtracting 1. So let's go ahead and divide all these x's by 2. That gives me -1, -0.5, 0, 1, and 2. All of my y's, I'm going to subtract 1, so that's -3, -2, -2, 0, and -2. So let's see where this ended up. So -1, -3, -0.5, -2, 0, -2. So you can already see how it's getting squished horizontally to create that horizontal compression. 1, 0, and 2, -2. I'm going to go ahead and connect. There's my triangle, my flat piece, and my other linear piece. All right, that was the very last question for this test review. I really hope this video helps you get prepared for your upcoming test. Good luck!